we have all these wearable devices, and you and I were talking about this backstage. Really exciting products, but they collect a ton of data.
Right.
And we have mobile apps, we have web apps that collect data, whether it's analytics or click rates, whatever it may be. But with wearables, we collect a different type of data, what you and I referred to as human data. So our heart rates, brain waves, all kinds of stuff. First off, tell me what your thoughts are on human data. What is human data, and what do you think about it?
Well, I think it's what you mentioned. It is this crazy phenomenon we now have, where we are broadcasting more than we ever have, just by our very respiration, our presence, our movement, that kind of thing. And it's great, but if you think even 10 years ago, if someone said, can I record all of your biometric information and put it in the cloud, you would say no, right? And yet today we do it every single day because there's a benefit, there's a value on top of it for us allowing them to actually take this data and do some analysis on top and tell us what's interesting about that data, whether it's a Jawbone Up or a Fitbit or something else. But it really is data that is coming from you, or something that is observed about you by something that's ambient or around you, or something that's derived from that data. So that's when it starts getting really complex, because there is this notion of data that you create and that you authorize to be put somewhere for later analysis. But if you think about the 15 to 20 billion devices we're going to have connected out there by 2020, where the number is, I think it goes up every time I read a stat, it goes higher. I'm pretty sure it's about 14.7 bajillion devices, as I last saw the number. When you think about that, these things are actually, in many cases, not something that we own. And we don't even know they're there in some cases. And so then you have that observed data, and then from there, like I mentioned, that imputed or data which is then derived from those other pieces of data, that's all human data. Right. But the question is, who owns it, and how is that going to work? Right, and that's, so you already asked my question. Well, I was about to ask you. It's a good follow-on, that's why.
So you talk about data that's collected from observation. So I mean, there's one level of data that comes into play of who owns it from my smartwatch. But when it's data that's observed, who owns that? I mean, where do those worlds collide, and where do they divide? I mean, who owns what and where?
Yeah, there isn't actually a great answer yet, which is kind of the scary thing as we kind of rush headlong into this collection of all this data. At Davos, the World Economic Forum, they've got a personal data project which is attempting to reconcile what to do with all this data, because there is this interesting matrix you can create. You do have this notion, the left rail, you've got data that you kind of push out there, you've got the observed and you've got the derived data, and the top you've got who ostensibly owns it. You've got stuff that you yourself own, stuff that is shared ownership, so maybe you and somebody else own it, and stuff which is public domain, stuff that nobody owns, basically, or everybody owns. And if you actually look at that grid and you do the actual computation inside the grid, only one out of those 9 boxes could you actually say you yourself could lay claim to as owned data, which means 8 out of those 9 different types of data you don't have a sole claim to, which is bizarre when you think about it, right? And it's actually a little bit scary, or opportunistic, depending on how bullish you are on the whole thing, because it is one of those things where if I take data you give me, say your zip code, right, and then I take and then something else takes your location data from a device you have on your body, and I compute basically that you are likely to be going to some bar based on your zip code and your likely location data, that really isn't owned by you anymore. Now, I've run a computation, not me being, but the industry has run a computation, expended compute power, expended electricity to derive that piece of information about you. So then the question comes down to, who owns that?
So it's really a question of who owns, and who owns, and who owns. It's a continuation of going down. Do you think that we'll come to a regulating state? So, right now, I mean, we have some data that we give to the government, some data that the government can see, some data is quote-unquote private, but as again here comes back to the same question of who owns that. Do you think we'll get down to a state where we are regulating that data and we know what you and I own and what the company that we're wearing the product of owns? Do you think that's going to happen?
I'm not sure regulation is the right model. If you look at Hollywood actually has a very interesting way of dealing with this problem. And Mark Davis, one of the guys involved in the Davos panel, he talks a lot about rights clearances. So, for example, if you make a movie, you go and you get a piece of music for something, and you get a brand in the background of a shot. You may get a catchphrase like 3P that someone has used. And there's literally a very complex mechanism of rights clearances, and that you have to literally go to each of those different owners of those copyrights and trademarks and say, can I use this? Do I have to compensate you for it? All that sort of thing. So there could be something like that for digital data where we actually have almost like a bazaar of rights clearances. But there still comes down to that fundamental question of if the industry actually does spend a lot of compute cycles to derive some very interesting nugget about you that you haven't explicitly given, I'm not sure who does own that. Now, I think you should be able to, is my personal opinion now, I think you should be able to actually extract out the components that were used to make that derived attribute. So I should be able to say, I no longer want you to use my zip code for anything, and anything that was derived from that zip code, even if you had hundreds of implicit or observed signals about me, that zip code piece should be yanked out. Practically, if those of you who are in computer science, how you ever do that, it'd be hard.
But if you know how to do that, there's probably a lot of people who'd be willing to hire you right now. So,
Yes.
so definitely figure that out. So to another question, privacy. So, we're talking again back to the data that's been observed. How does privacy play a role in all this? With wearables, that's probably one of the bigger questions outside of battery life is the privacy of the data that's being collected. If we don't know who owns the data, and we don't have any security around that, how does privacy play a role in the data?
I think it's still evolving. No one has a good answer here that I've seen. I've done a lot of research on this to see who is thinking about this, and there is no right answer. There's no generic blanket answer you can give. It is one of those things where we're going to have to figure out as we go along, and I think it's probably going to take something that happens, some unfortunate event or even fortunate event, to get people to actually think about what we want to do and how we want to think about this data in aggregate and in isolation. But it all comes. So when we do privacy at Microsoft, we always think about. We look at the value we're giving the user based on what information they're giving us. In other words, we try not to ask for more information than we need, because A, it's dangerous to keep PII you don't need for many reasons. But B, there's kind of an implicit contract there, which is if you give me this information, I can give you a better service. And the second that we get more information than we need to deliver the better service, it becomes, frankly, a liability for us and kind of a risk. And I think that might be where we end up with the wearable data and the human data, is that some companies, both for privacy reasons and liability reasons, but also for rote computational reasons, they may just say, I don't actually want all this data. I was talking to a guy who used to work at Yahoo Labs, Anand Kool, who's a really amazing data scientist and architect, and he was talking about how, imagine if literally you were collecting all the data from all the smart plugs in your house. So literally 60 times a second, every cycle, the plug to report back information as to whether it was being used or not. So you have 60 signals per second times n number of plugs in your house. Say you have 100 plugs times 3,600 seconds in an hour times 24 hours a day. You can quickly begin to see the amount of data that you could collect, and that we oftentimes in this industry have wanted to collect all data, is simply overwhelming and frankly unnecessary. And so I think we are going to begin to see, as we do get 20 billion plus very, very chatty devices on IPv6 networks, we are going to begin to see all of us in the room looking at sampling techniques or extrapolation techniques where we actually will probably discard more data than we collect, just because we don't, today at least with classical computing systems, we don't have the capability to actually process it in any real-time meaningful way.
So do you think wearable devices right now are collecting too much data, or do you think they're collecting a little bit too less? I mean, where do you think we are in terms of data collection with current wearable devices? So maybe even a better question, to not go so general, is some of the wearables that you wear,
right?
Whether it's the Pebble Watch or the,
right.
Another smartwatch or the Misfit, are these devices, as great as they are, collecting just the right amount of data, or do you feel like we might be over collecting data?
No, I don't think they're collecting enough. Obviously, honestly, I think there is probably an opportunity. Because today they're very single purpose in many cases, not all cases. Phones are very multi-purpose, but the Misfit's a fairly single purpose-ish device, the Jawbones, all those types of things. And so and I don't mean that derogatively, I just mean that they do one thing very, very well. And so I think today they are probably collecting maybe not even enough for what they could do. Like what I want on my Jawbone, for example, on the up, Today it basically detects movement and whatnot and sleep patterns. But what I want to detect light, so it could actually figure out when it's getting light outside. What I want to detect what I want to detect sound, so I could hear if I'm snoring or not, and optimize the sleep notifications that it gives me. So I think there's actually opportunities there. I think today we're still in the nascent part where we're building not single-purpose devices, but devices that aren't necessarily as powerful as they could be, both because they don't know what we do with the data, but also just because of the sheer size and space and battery constraints that we have with ICs today on many of these things.
So because a lot of these devices are either paired or they're working on Wi-Fi, another thing that we were talking about backstage is network injection. So going back to privacy and even security, how does this play a role right now? I don't think we've really had an issue where someone has kind of injected through network connectivity as we're exchanging information back and forth with Bluetooth. Do you foresee that as a problem? And if so, again, how does the ownership issue play a role in it?
It all comes down to the value of the data, right? So right now, no one's likely going to bother with a man-in-the-middle attack to figure out when I went to bed last night.
Well, I mean, there might be a few people.
Probably so.
There's a few people in the audience who probably are interested
who might do that.
Right.
We're talking an analog watch today for that reason. So today, I don't see it as a huge thing. I do think we are going to begin with, as we're seeing white space open up, the white space, the FCC open up all that great, beautiful, gorgeous bandwidth in the 700 megahertz range. We see picocells. I'm just so excited for the big, fat waves of long distance, low power data we can start pushing out there. And you have picocells popping up. I think the notion of tethering will be a little bit outmoded, as long as we can do something with batteries. You know my rant on this. It's all I ever talk about is how messed up batteries are. But assuming we can make some decent material science breakthrough on battery and energy storage and energy density, and the 700 megahertz stuff doesn't get polluted with radio control cars and everything else, I think we're going to begin to see actually less of the tether and more of the direct communication to the web. And thanks to IPv6 is now how we actually can handle the address space we need to do a lot of that. So there, I think the security problems and privacy problems we're going to have are much the same as we have today with PCs, with Macs, with devices. It's just but it all comes down to how much value is on the actual device. Like I'm so excited for my new coin card. Have you seen the new coin card?
I have one. I have one coming.
Well, so do I. Mine's free though because I already referred 20 people. So you get $5 per referral, just so we're clear. I'm not missing out on bargains these days. But that's you figure that's actually now it doesn't have. I don't believe it has radio. Yes, it does actually. It has Bluetooth. So that's a honeypot. Now I'm sure they're doing amazing work to secure that, but it is a honeypot when you think about that. So that's as we get more of the value stored in these devices and they're chattier, then we have I think a bigger challenge. One thing I'll say on this, which I think is totally fascinating, who was it? It was I can't think of the security researcher. It wasn't Bruce. Maybe it was Bruce Schneier actually. He wrote an article recently looking at the state of devices that allow us to talk to the web. So think of all the routers we have in our homes, all the Netgear routers and all the Linksys routers we have in our homes. And he did the analysis basically of the current state of software on these things. And many of them, forget Linksys and Netgear, go to like the knockoff, the cheap ODMs we buy for $10 for a router for our back room. They're oftentimes running super outmoded Linux distributions that are 6 generations old. They come in a binary blob on the device, so you can't even patch it. You literally have to rip and replace the whole thing. In many cases, these companies who sell them for $10 have no servicing model. So I bring this up to say, if we think about devices in that sense, where they are, that one especially, that connects my whole network to the web, and it's probably the most insecure piece of system that I possibly have, and it's not patched, and there's no way to patch it, and I can't reverse engineer it, and I can't see the binaries, I can't do anything. I think that model, which is great for getting things out quickly and cheaply, it's a really bad model for wearables. Right. As we start putting more and more personal data inside of those, I'm not sure in the race to make everything less expensive and get it out faster, I do worry about us grabbing things off the shelf that are perfectly good distributions of Linux and whatnot, but if you can't service them or if you haven't got a commitment to long-term servicing, that's I think a serious issue for wearables long-term.
Well, and it plays even a deeper role. I mean, wearables for you and I, there's certain data that gets collected, but think about the families. So think about our families. Yeah. You've got a child, and you're collecting data on the child. That data then gets back into that $10 router. It's now connected into the home with your refrigerator. Yeah. You can start to see these things, and if someone was able to get access to any of that data, I mean, that could be detrimental to someone in the family.
Very much so. Yeah.
This is-
So I think the bottom line is go buy industrial grade routers for your house that have servicing models from big companies.
If it's $10,
That's what I did.
don't look for the bargain router. Just look for the
Yes,
bargain
$2
deals
bargain.
where you refer people and you get $5 off.
Good idea.
So this topic is very important to you. You were telling me, and we're going to release it and make it public right now. You're writing a book, or you wrote a book.
I
about
wrote a
this.
book,
So can you
yes.
tell us a little bit about that book? I know it's not out for a little bit, so
Yeah.
sorry everybody, you're going to have to wait. But tell us a little bit about this book and how it's relating to what we're talking about.
Well, it was fun, actually. I finished it about 2.5 weeks ago, I guess. I got my editors giving it back today. It's out November 4th. Mark your calendars. I'm sure you can't wait to go to Borders, if it still existed, and buy it. But the idea really is the increase in digitization of the entire planet, partially created by this proliferation of devices and wearables and whatnot, and what that really does for search in general, and how search, because of its better access to the entire planet, search is actually able to better bridge machine intelligence and human intelligence into something which makes us all better, makes us more informed, makes governments more transparent, makes society in general more even and more equal, because we're able to actually now apply the machine intelligence we built to handle search to really almost a complete and high fidelity copy of the physical world. And that's what's really exciting to me about sensors and devices in general, is that every single day we're building a richer and richer copy of everything around us. You know, in Bing we have this thing, the code name is no longer a code name because it's trademarked, so we have a thing in Bing. We call it the Knowledge Repository, I think now. Super awesome name.
You are so excited about that name.
The code name was so epic.
What can we
No.
That's
I
even
can't.
worse
I got
than
a
tease.
C&D from the guy who owns the copyright. So, which is that's his copyright. He should own it. It's his
We have to
trademark. It's
respect
fine.
it.
We do.
Respect it.
It was an internal code name. But anyway, I digress. So we have about 35 billion objects inside of this thing. So those objects range from this microphone to that pair of monster headphones to probably those chairs out there. And what's really happening is we're able to recreate everything in the world, all the relationships of all those things inside the world, all the people in the world. We have about 1.2 billion people in the system right now with all the relationships cataloged and everything else. And what that does is when you have that level of fidelity, you're able to apply collaborative filtering models and Bayesian models and all these deep neural network models to start to predict or help augment outcomes in ways that are positive for society. And so that's, to me, it's one of the most exciting epics of technology that we'll ever have seen. And I think people always say, well, with more data doesn't equal more precision. I totally agree with that. I could go on for hours about causation. But the reality is, if you look at something like functional genomics or look at systems biology, there was a time 15 years ago where people would say, we can't possibly model cellular interactions. There's too many possible variables to say, if you do this, then this will happen inside the cellular structure of our bodies. And as we actually began to get higher and higher resolution and higher fidelity MRIs and functional MRIs and scans, and we were able to see in real time all these things happening, suddenly we can do these calculations. And there's an old axiom in physics, that there's the butterfly who flaps its wings in Australia and the thunderstorm occurs in South Dakota 2 days later, and we know there's a causation there. But we don't know how to actually show it. Well, the theory, of course, of the book really is that because we're getting so much more data, we actually will be able to begin to, just like systems biology, just like functional genomics, we will be able to actually start modeling these real-world interactions of tiny things in ways that actually give us these almost superpowers to see beyond what we can see with our naked eye and with our brains today. So it should be fun.
So do you see? First off, I'm going to get a pre-ordered and signed copy.
I'll give you one.
I appreciate it. First edition. But do you see wearables playing a very strong role in that? So I mean, with the prediction model. Something like a smartwatch or a monitor, being able to gather that kind of information and predict, do you think you'll be able to, not only, again, wearables play a role in that, but you actually being able to select the prediction model that comes? So for instance, if I want to know if my child's going to be sick, I get device X and Y, put that together and can create almost a funnel of sorts that will give me that.
Super cool. I hadn't actually gotten that far in my head.
Well,
wow.
I just gave you
I
book
think
number 2.
You just got the second edition right there. People would have to get savvy enough. I mean, this room, I think we'd all be really excited about this opportunity to say, if I get N number of devices, each of which have a discrete set of information streams that get spit out, And we could then be told that certain systems could correlate and corroborate that data and make a prediction that I'm sure I would go buy that. I think that the real challenge is scale there. And I think what wearables generally provide to us is that, and it's not just wearables, it's devices generally around us, right? But wearables do provide us, again, that very rich level of fidelity that takes the physical, corporeal beings that we all are in this audience and makes them into a machine-readable format. And we've never in the history of humankind had that capability. We've never had the level of fidelity that we have today in a machine-readable format. And wearables are going to obviously help augment that.
So you mentioned search, and you're with Bing, so let's talk a little bit about search and wearables. Do you see, search playing a role with wearables as it did with social? I mean, we had for a while, social was behind a wall, and then we integrated search throughout, and we were able to start searching, tweets and Facebook posts and the like. Do you see that being the case for wearables, or do you see that situation even occurring where search plays a role?
It's funny, probably. I'm not sure it'll be the same thing as like social, though. I mean, so when we look at search nowadays, it's much less you go to a something.com, google.com, bing.com, yahoo.com, and type in a keyword and get a response. That's certainly something that we can do, but it isn't really where the long-term value of search is going to be. And so much of the stuff that we've done and Google's doing too is looking at how you can break apart and tease apart all those components of search and then apply them in discrete or interesting methods. So we can tease out speech recognition, intent derivation, object understanding. We can tease out NLP, natural language processing, utterance, all these things, gesture-based support, all the things that we have to build a search engine. We can now kind of pull those out and sprinkle them across different applications. And so to answer your question on wearables, it probably will not be something you go to a keyword-based search type model and say, am I fat? And have your wearable tell you, you're looking a little chunky. But there probably was going to be something where we take the parts of search, whether it is the environmental understanding or the big models. We just released a model yesterday called Clearflow, which looks at turbulence in the air of airplanes, then is able to model wind predictions from that all across the nation. So it's really, really cool. But it's an example of how a sensor which is not designed to do that, the data that was collected from all those airplanes traversing the skies above us actually then lead to our ability to predict windstorms and everything else on the ground. And it's another example of how more data and more sensors, and wearables, you could kind of assume that the same type of thing. As we're walking around, maybe there's carbon monoxide sensors built into your new smartwatch. So suddenly now we can begin to see where if we see smog moving in, or if people have asthma, to direct them to move out of the way. Those are all search-powered functions. That's the same kind of core tech that we could use to do that, but for a very different application than we think of when we think of search today.
Right. I guess part of the reason I thought of that question was back to the original topic of who owns the data. So, for instance, if a search engine, their parent company, were to make a wearable device, the user creates a profile, generates data. And if that profile was able to be accessed from the web, could it become public?
Oh, wow.
So very similar to our Facebook. So both of our Facebook profiles are public and yet private due to some really exciting photos that we have together from birthday parties.
That one time.
That one time, the tiger.
That tiger was awesome.
But so just like that, our Facebook profiles were locked down for quite some time.
Yep.
And then due to partnerships with various search engines, yourselves included, we were able to start searching that. So do you see the same thing in that respect?
Yeah, that's interesting. I don't. Yeah, boy, it depends on the functionality, and I'm not smart enough in the wearable space per se to know what that would generate. I can't imagine. That's not true. I can imagine. I can't imagine a practical application of my biometric data to a search in a public way. I can see it being used personally a lot. But man, oh man, I struggle to see how we could actually use that in a responsible way that wouldn't just violate so many social norms and ideas that. But never say never. I mean, I can't think of it, but doesn't mean someone in the audience or a kid who's 12 in Sweden couldn't think of it.
So anybody in the audience, if you have
or if you're a kid who's 12 in Sweden, let me know.
So coming back full circle, it looks like we are still not at a point to know who owns what data in this industry.
No.
Along with privacy and the privacy of that data.
Yeah.
And it's something that we're going to grow and get to. But right now, the best that we have is privacy policies and
It's policies, and I think
opt-outs.
it's opt-outs. It's also just being aware of what you're putting out there. And again, you don't control it all. There's observational and derived, which you have almost no control over unless you wear a bag over your head and shut off all your radio communications on your body, which I have seen people down in Tenderloin actually do. But other than that, you likely can't stop being observed. I was just reading an article recently that's I can't think of the company now, but they've actually worked out a way to identify a face with as few as 60 pixels between the eyes. So imagine a face on the screen, 60 pixels between the eyes. That's a very grainy. It's basically a surveillance photo from a convenience store. And there's software packages now which even on axis. So if I go like this, and you have 60 pixels between here and the camera's here, we can begin, not we, this other company's name I've forgotten now, can identify, it's in the book, can
November 4th.
Can identify the person. So and that's today. And I guarantee within a year we're going to have 40 pixels and 20 pixels, and now basically it'll be a gray blob. We can figure out who you are based on your scent or something. So yeah, I think the takeaway is who owns the data is not clear. Certainly we own part of it, stuff that we derive and stuff that we put out there and stuff that we control, but the vast majority of data, just if you look at the grid, this isn't a policy thing, I'm not saying this should be the way, it is the way it is. If you look at that grid of all the ways data can be generated and all the different ownership models, we as individuals likely own very little of it today. And how that manifests itself in future products and how it manifests itself in future services is something that I think we in the industry who are building these things have to be very strong about. Like, we cannot allow this to be another data mining operation, because forget governments, forget policies, it will kill the industry, period. You will have such an absolute blow up of people freaking out, rightly so in many cases, about what's happening with this data that they have no control over, that unless we all are super responsible at how we think about utilizing it and building it and monetizing it, I think it's a very dangerous slope.
So everybody be responsible.
Happy.
Yeah. Thank you guys very much, Stefan. Thank you very much. Everybody be responsible.